Today we're going to do a fun activity to demonstrate a few genetic principles. We're going to build a dragon. Now what I have here are simple popsicle sticks. So it's easy, it's cheap to make, and as you can see, we've got a female dragon, which is the mummy, a male dragon, the daddy. And we're going to see what baby dragon looks like. Now, we have two green autosomes, two yellow autosomes. You remember that the autosomes contain the normal characteristics that determine body shape, size, all other traits. And then we've got the sex chromosomes, the red one for female, the blue one for male. Let's take the green autosomes first. On the one side, you've got the alleles for a few characteristics. On the other side, the other allele that makes up the allelic pair for specific genes. Good, and the same for the yellow autosomes as well as the sex chromosomes. Now the first principle we're going to demonstrate is random assortment. Now unfortunately we cannot do crossing over with popsicle sticks, but let's have a look. And so we're going to look at the green autosomes, and you be my secretary and write down. Let's have a look. Mum has got a capital W, a small w, two small r's, capital A, small a, two small r's. Yeah, that's fine. Capital A, small a, and two small c's. Now the W is the gene for wings, the L for the length of the neck and the tail. Long necks are dominant, long tails, and the A is for the white body with no freckles at all, and the C is for the color of the body. Now there's a second principle. We're also going to demonstrate epistasis, and I'll come back to that later. Now let's see. So that, you can have a look at that quickly. To a big and a small W, two small L's, two small a's, and a capital C and a small c. Now let's see what baby dragon will have. I'm going to take the female autosome, spin it, and see which side is at the top, and that will be the alleles that baby inherits from mum. It's a small w, in other words, recessive, having no wings, a small l, small a, and a small c. Let's see the green autosome for dad. Spin. Right. From dad, baby dragon inherits small w. Now all of them are recessive, that all the alleles he inherited from dad. Small l, small a, small c. Now let's look at baby's traits. If we look at the paper, we will now see that baby inherited two small w's. Having wings is a dominant trait, not having wings recessive, homozygous for recessive, so baby won't have wings to fly with. What good is a dragon without wings? We'll see. Shame. Anyway, both parents, interestingly enough, are homozygous for the tail. In other words, they have short necks, short tails. Baby will also have a short neck and a short tail. Let's skip and go to color. A capital C will mean the body is dark green. A small c will mean the body is light green. Baby has two small c's, so baby's body will be light green. However, if baby inherited the homozygous recessive condition of A is the gene that determines whether pigment will develop or not. Which means that if baby inherited a capital A from one of the parents, he would have been light green. But because he's got the homozygous recessive condition for no pigment at all, the baby's body will be white, and in other words, the double C, the homozygous recessive condition for the color, will be in epistasis to the pair of alleles for pigment developing or not. In other words, in simple terms, if the baby has got 2 recessive alleles, no color will develop. If it was 1 dominant and 1 recessive, the baby would have been a color. And if we look at our next, the yellow autosomes, when we get to that, we will also see that there is a gene for freckles or not. And whether the baby inherits the combination to have freckles, he will not, because of that condition. And that is what epistasis is. And so we can continue. Thanks, Ansi. Now let's have a look. We can spin the yellow autosomes, we can spin the sex chromosomes. If we look at the sex chromosomes, remember, female XX and male XY. Now here is a sex-linked condition. It is not a disease, however, it's simply a condition. If the baby receives the 2 X chromosomes with the capital H's, it means it's a girl, and it will have a horn on the nose. If the baby receives the 2 X's, 1 dominant, 1 small, it will still have a horn. But if it's an XY, where we don't have the allele on the X chromosome, the baby will have no horn on the nose. Okay, and just one other thing to make things interesting. If it's a male baby, it will have a spike on the tail. If it's a female baby, no spike. That is the difference between boys and girls in dragons. So let's have a look at a completed form where we filled in everything. There you can see, like Ansi did, our mum and dad's genotypes, the egg and the sperm, the alleles, the traits of the baby, the mum and the dad. And here you can see, for being a fire breather, 4 toes, 3 toes, or an extra toe. Interestingly enough here, the heterozygous condition is incomplete dominance. So you will find that whether it is where you will find the homozygous recessive trait, there will be 3 toes. Heterozygous, 4 toes, and homozygous for the 2 capital traits. In other words, the dominant trait, you will have 5 toes. And the same goes for the freckles. So freckles and number of toes is also incomplete dominance. So let's have a look at this baby dragon. And this baby Snowy. Yeah, if we look at the completed table, you can see, even though the genetic composition says light green, the baby will be white because of the no white, no freckles combination, no pigment. Some freckles, however not. There's your white baby, no freckles, a horn on the nose, a short neck and tail, no spike because she's a girl, white, no freckles, and she can breathe fire, so watch out. Okay. Now this activity is fun, but you can demonstrate and you can learn various genetic principles. And if you want to know more, you can find the worksheets on the Teaching Biology Project website, and the reference to the website where I found this activity, it's on the Bryn Mawr website, will also be found there, so that you can go and have a look. And there you've got your baby parts. Have fun.